Welcome to question 9 of the 2017 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 9 we have the graph of f with the domain of 0 to 1 with a rule of f of x equals the square root of x times 1 subtract x is shown below. For part A we want to calculate the area between the graph of f and the x-axis. So that's this area just here. So we know that the area is related to an integral, but before we do that, we're just going to express f in a slightly different form. So f of x, if we expanded the brackets, would give the square root of x subtract x square root of x. So therefore, f of x could also be expressed as x to the power of a half minus x to the power of this would be equivalent to 3 on 2. So that's just going to make the integration that we're going to perform a little bit easier in a moment. So the area, which is what we're asked to find, is equal to the integral between 0 and 1 of the function f of x, which we're going to use x to the power of a half minus x to the power of 3 on 2 dx. And now that is going to equal, and we're going to have x to the power of a half, we're going to add 1 to the power, so we'll have x to the power of 3 on 2. And then dividing by the new power, so dividing by 3 on 2 is the same as multiplying by 2 on 3. Then we do the same for this next term and we add 1 to the power, so we get x to the power of 5 on 2. And then dividing by 5 on 2 is the same as multiplying by 2 over 5. And we're going to evaluate that still between the terminals of 0 and 1. Now to evaluate this, we're going to substitute in our upper terminal of 1. And 2 times 1 to the power of 3 on 2, well 1 to the power of 3 on 2 is simply 1, so we just get 2 on 3, and the same logic can be held here, where we put 1 into here, and 1 to the power of 5 on 2 won't change, it will still be 1, so we'll just have minus 2 on 5, and then we substitute in the lower terminal, but substituting 0 into both of those terms just leads to subtract 0 overall, so this is going to equal. And to answer this question we just need a common denominator, so we'll need 15. So this is the same as 10 on 15, subtract 6 on 15, and that equals 4 on 15. So that is the answer to part A of this question. So from the examiner's report we can see that almost 50% of students got this question correct, and that the examiner goes on to state that concise and correct solutions were produced by many students. Common incorrect approaches included treating the integral of two functions f and g multiplied together as being able to be split up over the multiplication sign, which is not correct, or splitting them up into a sum of the integral of the square root of x plus the integral of 1 minus x, which is also not logical working. Other students struggled with the manipulation of rational exponents. For part B we have for x in the interval 0 to 1, show that the gradient of the tangent to the graph of f is given by 1 subtract 3x divided by 2 root x. And now just before we get into this question we're going to recall that f of x we found before could be expressed as x to the power of a half subtract x to the power of 3 on 2. So now if we want the gradient of a tangent to the graph, that's really just asking us to calculate f dashed of x, which we know how to do that. So we're going to have a half times x to the power of, and we're going to subtract 1 off the power, which gives negative a half. And then we'll have subtract the second term, and when we take its power at the front, we'll have 3 on 2, x, and taking 1 off its power, we'll go from 3 on 2 to just 1 on 2. So as this is a show that question, we need to show as many steps as possible before arriving at the answer. So 1 half times x to the power of negative a half is the same as 1 divided by 2. And the negative will bring this down to the denominator, and having a half there is the same as the square root of x, so that first term is 1 divided by 2 root x. Similar logic for this, the half turns it into a square root, so we're going to have 3 square root of x on the top line divided by 2. And then to get to the required form, we've got a common denominator, so we're going to multiply this second fraction by the square root of x over the square root of x to get a common denominator. And that will give us 1 subtract and 3 times the square root of x times the square root of x is just 3 times x, so that's going to be on the top line. And then on the bottom line, we just have the common denominator we just found, which is 2 root x. So that is what we were asked to show for this question. So from the examiner's report, we can see that a bit over a third of students got the full marks for this question, and that the examiner goes on to state that when answering show that questions, students should include all steps to demonstrate exactly what was done. But many students often left steps out of this show that question. A common pattern was to go straight from the first line of differentiation immediately to the final line, with no indication of obtaining a common denominator. So that was an essential step in this question. The edges of the right-angled triangle ABC are the line segments AC and BC, which are tangents to the graph of F, and the line segment AB, which is part of the horizontal axes, and it is shown to the right. Let theta be the angle that AC makes with the positive direction of the horizontal axes, so that's this angle here, which is marked in green, where the angle theta is greater than or equal to 45 but less than 90 degrees. For part C, we want to find the equation of the line through BC in the form y equals mx plus c when theta is 45 degrees. So that line BC is this line segment here that I've just highlighted in yellow. So we know that if theta is 45 degrees, then the gradient of the line segment here must equal 1, and that the gradient of this line segment must equal -1, as we know that this is a perpendicular line between AC and CB, so their gradients multiply to be -1. So if we know that the gradient of BC is equal to -1, then we know the equation of the derivative, which we found previously, is also going to equal -1. So therefore we're going to solve 1 subtract 3x divided by 2 root x is equal to -1. So therefore we know that 1 subtract 3x must equal -2 root x. So that line's obtained by multiplying both sides by 2 root x. And now this is a familiar pattern to us, which happens in a fair few of these exams, where the power on one x term is twice that of the other x term. So this x here is the same as x to the power of 1, and this is x to the power of a half. So what we get is a quadratic nature to this equation, which we can easily reveal by letting, say, the variable a equal the square root of x. So therefore our equation becomes, and we have -3a squared, and this term here is the same as this -3x here, and then we have plus 2a, and that occurs by adding the 2 root x to both sides of the equation, and then we still have the plus 1 equals 0. And now our job is to factorize this. So just before we go about factorizing it, I'm just going to get rid of the negative that's on the 3a squared by multiplying every term by -1. So I get 3a squared minus 2a minus 1 equals 0. And then this requires us to factorize. So to help do that, I'm going to multiply the coefficient of a squared by the constant. So we get -3. We're going to look for the factors of -3 that add up to -2. So they are going to be 3a squared, and then the factors of -3 that add to -2 are -3, so we get -3a, and plus 1, so we get plus a, and then there's still going to be -1 equals 0. And now one more step here. We factorize 2 and 2. So the first two terms, there's a highest common factor of 3a, leaving behind a subtract 1. And then for the next two terms, the highest common factor is plus 1, leaving behind a subtract 1. And we know that is still equal to 0. And now continuing our working up here, we factorize out the a subtract 1, leaving behind 3a plus 1. And that is still going to equal 0. And the null factor law tells us that a could equal 1, or a could equal -1 on 3. But we know that a was simply the square root of x, so we have the square root of x could equal 1, or the square root of x could equal -1 on 3. Now there's no solution to the square root of x equals -1/3, but we do know that the square root of 1 is 1, so that means that x is 1. And now we know that BC is a line with a gradient being equal to -1 and passing through the point where x is 1, and we already knew that when x is 1, y is 0, and that was from the graph that was shown. Or you could sub 1 into the rule the square root of x times 1 minus x, and you get y equals 0 out. So if we know the gradient of a line and a point that it goes through, we can use the formula y take y1 equals m times x subtract x1 to find the equation of the line. So substituting to this, we'll have y take y1, well y1 is 0, so we'll get y take 0 is equal to the gradient of -1 times x take x1, which is 1. And now solving that for y, because we need our final answer in the form y equals mx plus c, we just get y equals, and expanding the brackets on the right hand side, it's going to be -x plus 1. So that is the answer to part C of this question. From the examiner's report, we can see that 17% of students got full marks for this question, and a large percentage, 77%, got no marks for this question. Many students recognised that m equals -1 was the correct gradient that we needed for the tangent BC, but were unable to fully determine the point B10 due to insufficient working. Students had difficulty solving the gradient equation equal to -1, and the highest scoring responses were students who used a pronumeral such as let a equal the square root of x to help in their working. This created the correct answer versions of a equals -1/3 or a equals 1, and then we could just remember that a was the square root of x. Students should be made aware that squaring both sides, which was a potential way to solve this problem, does in fact introduce extra solutions. Some students found the equation of the line through AC rather than through BC, which was what was asked for this question. For part D of this question, it says find the coordinates of C when theta is equal to 45 degrees. So this theta here, if it's equal to 45 degrees, then we know that, like before, the gradient of this must be 1, and the gradient of this line must be -1. So the first step here is actually going to be to find the equation of the line AC this time. So this will follow pretty much the same format as part C, where we're going to equate the gradient 1 subtract 3x divided by 2 root x, but this time with +1. So that will give the equation 1 subtract 3x is equal to +2 root x. And then we can let capital A equal the square root of x like we did last time. So therefore we get, and I'm going to do this slightly quicker, we're going to get 3a squared plus 2a minus 1 equals 0 as a suitable quadratic to solve. And now we're going to factorise quickly, so this time I'll just write down that this could be factorised as 3a subtract 1 times a plus 1 is equal to 0, and that would give us that the square root of x could equal +1/3, or the square root of x could equal -1. However, there's no solution for the square root of x equaling a negative number, so there's no solution. But for the first part of the equation, the square root of x equals 1/3 gives x equaling 1/9 as the value for x which we need. So if x equals 1/9, we get y equals the square root of 1/9 multiplied by 1 take 1/9, and that would give y equals the square root of 1/9 is 1/3 times 1 subtract 1/9 is 8/9, which equals 8/27. So therefore AC is a line with a gradient equaling +1 and passing through the point, which is 1/9, 8/27. So just as we did with part C of this question, we're going to use y take y1 equals m times x subtract x1 to find the equation of the line AC. So this will give us y minus 8/27 is equal to the gradient, which is +1 times x subtract x1, which is 1/9. And this will give us y equals, and on the right hand side we'd get x, and this would be minus 1 on 9, which is the same as minus 3 on 27, and then we add 8 on 27, giving positive 5 on 27. So that's the equation of the line AC. And now the whole point of finding the equation of the line AC is that the coordinates of C are the point of intersection between the lines with equations x plus 5 on 27, and that being equal to the line we found before, which was negative x plus 1. So adding x to both sides, we get 2x equals, and we're going to subtract 5 on 27 from both sides of the equation, which on the right hand side would leave us with 22 on 27. So therefore x would equal 11 on 27. And now if x equals 11 on 27, we could find y is equal to negative x, so negative 11 on 27, plus 1, which is the equation of the line for BC, the slightly easier one, I think. So therefore, y is going to equal 16 on 27. So the coordinate that we're asked to find for the point C is going to be 11 on 27, comma 16 on 27. So that is the answer to part D of this question. So from the examiner's report, we can see that only 9% of students got full marks for this question, and a whopping 75% of students got 0 marks for this question. So the examiner's report goes on to state that many students did not attempt this question at all. There were, however, some successful responses. These students knew to equate the equation from part C with their equation in this question, which represented the line AC, and solve these equations simultaneously. A common error involved calculating the coordinates accurately.